As you will learn in this chapter, the value of a bond is simply the present value of the bond's future cash flows. Many of the problems in this chapter are time value of money problems. Please review the abbreviations before proceeding to the problems for this chapter. The coupon rate is a percentage a bond issuer agrees to pay as interest each year. This percentage is expressed as a percentage of bond's par or face value. The face value of a bond is assumed to be $1,000 unless stated otherwise. So here the 9% is a coupon payment, is a coupon interest rate, and is paid semi-annually. And the face value of the bond is 1,000. So the coupon payment is expressed is multiplied by the coupon rate and divided by the number of interest payments. So in our case, the coupon rate is 9%, the face value is $1,000, and the number of interest payment per year is 2 because the bond pays interest rate semi-annually. So the coupon payment is $45. The bond price is the present value of each of the interest payment plus the present value of the face amount, which will be paid in 14 years. Since the interest payments are equal in amount and occur at the end of each time period, they qualify as an ordinary annuity. So the maturity period of the bond in our case is 14 years and the face value is $1,000. The bond coupon payment is semi-annual and the market rate of return is 7.25%. And you will learn that 7.25% is the yield to maturity of the bond, is an yield of the bond. To find the bond price, this equation is used where since the bond is semi-annual is divided by 2 and the coupon payment is 0.06 times 1,000. So coupon interest rate is multiplied by the face value. So this equation will give you the present value of the bond is $891.20. Now I'll show you how Excel can be used to calculate the present value or the market price of the bond. Now, in this equation, the symbol C is the coupon payment and the symbol F represents the face amount. Since the coupon payments are paid semi-annually, the coupon payment, the interest, and the number of periods or payments are to be expressed in semi-annual terms. The current value of this bond is $891.20 given the market interest rate of 7.25%. Now let's see how Excel can be used. So here the bond price. So what I have done is the bond price, the interest rate, and coupon payment are expressed in yearly terms. So let's convert the interest rate into semi-annual frequency and the coupon payment also semi-annual to be converted into semi-annual payments. The number of years of the maturity of the bond is 14 years, but the payment is made semi-annually, so number of payments is 14 multiplied by 2, so is 28. So the interest rate has to be divided by 2 because it is a semi-annual bond, and the face value is the maturity amount, which remains $1,000. Now once we have those values, now let's see the coupon payment. What I've done is I've divided the interest rate by 2 and multiplied by the face value to find out the coupon payment from the coupon interest rate. To get the present value, we will use the present value equation, which is rate which is situated in the cell D4. This is rate, is an yield of the bond. The number of periods are 28, followed by the coupon payment, which is ordinary annuity or annuity, so it's 30, and the face value is 1,000, right? So that gives us the present value of the bond is $891.20. Now, if you use the financial calculator, you'll have to input those values for N for interest rate, for ordinary annuity, and also the value for face value. And then you have to press compute button to get compute button followed by present value to get this present market price of the bond. So you can see on the slide the number of time periods, the interest rate, and the coupon payments must all be expressed in semi-annual terms. Thus, there are 28 time periods. The rate per period is 3.625%, and each coupon payment is $30. The bond is selling at a discount because the coupon rate of 6% is less than the market value of 7.25%. And if you can compare the present value of the bond with the face value of the bond, the present value or the current market price is less than the face value of the bond or the maturity value of the bond. So it is when the present value or the current market price of the bond is less than face value, the bond is selling at discount. It is said that bond is selling at discount, and it happens when the coupon rate is less than the market rate or the yield of the bond. So here in our case, the coupon rate is 6%, which is less than the yield of the bond or market interest rate. And as a result, the present value of the bond is less than the face value of the bond. And when the coupon interest is less than market rate, the bond is selling at discount. Now let's turn on to time to maturity. So here it asks you to compute how many years is it until this bond matures. So should the problem be computed in terms of years or in terms of semi-annual periods? So the answer be expressed in years or in semi-annual periods. So since the interest is paid semi-annually, this problem is calculated based on semi-annual periods of time. So the interest is paid semi-annually. So this coupon interest payment is semi-annually. So if we solve this problem, we'll get the number of periods 12 years. The question asks for number of years, so you must divide 12 by 2 because this is number of periods, and the question asks for number of years, and the coupon payment is twice a year. So the number of years is 12 divided by 2, which equals 6 years. So the present value here is negative 976.54. Because as you would pay this amount to buy the bond is negative as you pay the amount to buy the bond. Both the payment and the future value are positive as you would receive the semi-annual interest payments as well as the bond principal at the maturity if you own this bond. So that's why the the PMT value is positive and the future value is also positive, because these are the amount you will receive and this is the amount you will pay when you buy the bond. Now I'll show you how Excel again can be used to find the time to maturity. Similar, what I have done is I arrange all those values which are given in annual term, then I convert it into semi-annual. So the interest rate is divided by 2. This is also divided by 2 multiplied by the face value. We know the present value of the bond is 976.54. What we require to find is NPER. And if you are aware about this function that we use in time value of money computation, this can be calculated by a function called NPER. So it asks you to get the value for rate, and the rate is 0.04. The PMT is the coupon payment, which is paid every 6 months. So it's a regular payment and is an ordinary annuity. So it's PMT is 37.5, followed by present value of the bond, and it must be with the negative sign. And also the cell for face value, and which is 1000, and then when you press enter you'll get this number of periods, but it asks you to find the number of years, so it has to be divided by 2 to get the number of years. So this is how Excel is used to find the time to maturity of the bond. The yield to maturity is the rate of return required by the market. So here, what time period should you use to compute this yield? So for the yield to look for the coupon payment is annual or not, or semi-annual, or it is quarterly. The coupon payment is annually. So the coupon payment is 5%, and so the coupon payment is 5% of 1,000 or $50 a year. So yield to and see here the current market price is $923.40, which is less than the face value of the bond. So the bond is selling at discount. In that case, the yield to maturity has to be greater than the coupon rate, because the bond is selling at a discount. So let's try to find the yield to maturity of the bond, and the yield to maturity of the bond is 7.28, which is higher than the coupon interest rate, which is 5%, and that is there because the market price of the bond is less than the face value of the bond. I'll show you. Let's now turn to Excel to find the yield to maturity. This yield to maturity is the rate in Excel. We have got the input for all the data, and since they are expressed annually, so we do not have to convert it into semi-annual or quarterly, because coupon payment is expressed as yearly payment. And also the number of years, we have the 4 years maturity of the bond. And now we use the function called rate, which is rate function requires you to give the value for NPER, which is 4, PMT is 5%. So what I've done is I multiplied the coupon interest rate with the face value, which is located in cell C20, and the present value, because you are paying the market price to get the bond, so is a negative, followed by C20, which is the face value of the bond. And then clicking OK will get you 7.28% as the interest rate of the bond. And since the yield to maturity is higher than coupon payment or coupon interest rate, and it has to be because the market price of the bond is lower than the face value of the bond. The current yield is equal to the annual coupon divided by the current price of the bond. So it is the division of annual coupon divided by current price of the bond. In our example, we'll have to figure out the current price of the bond from the data. The coupon payment is semi-annual, so we'll have to convert the yield to maturity into semi-annual interest rate. And then we'll find the current yield. You can use this equation to find the present value of the bond, and find the current yield. The annual coupon is divided by the current price of the bond. Now let's use Excel to find the current yield. So these are the data which are given in annual. I converted it into semi-annual. So the interest rate is divided by 2, coupon payment is divided by 2, and the number of years has to be multiplied by 2 because it's a number of years, and the payments are then doubled because it's twice payment in a year. So the present value of the bond is calculated by this function called PV, is followed by the rate, and then NPER, which is 22, PMT is coupon payment, which is coupon interest rate multiplied by the face value, followed by the face value of the bond, which resulted the present value of the bond is $1,105.84. And this is the bond selling at premium. Why it is selling at premium? Because its present market value or current market value is more than face value of the bond. And it happens when the coupon interest rate is more than the yield of the bond. In that case, always the bond is selling at premium. And to get this current yield can be obtained by dividing annual coupon with the present value of the bond. What is the annual coupon? Annual coupon is located in C30 cell multiplied by the face value of the bond divided by the present value multiplied by 100 to get the answer in percentage term. So it is 9.04%. Okay. And if you use the financial calculator, just insert the value for an interest rate, then coupon payment, and also the face value, and then compute present value will get you the answer of the present value. Right. Now, let's talk on the interest rate. The bond prices are inversely related to the market rate of interest. When the market rate of interest rises, the bond prices fall. Which bond do you think will have the greatest change in the price in this example? The short-term bond of 2 years or the long-term bond of 10 years? Okay, so what we have is we are trying to find out which bond is more sensitive to interest rate. And in first case, the price of a bond at a market rate of 6%. Now here, the yield to maturity of the bond is 6%, which equals the coupon payment. So the price of the bond equals the face value. And in second case, if the market rate increases to 7%, if the market rate increases to 7%, so here, when the bond matures in 10 years, so when the market rate is more than coupon payment, the market value of the bond will be less than the face value. So in our example, you see, when the coupon interest rate of 6% equals the market interest rate, the present value of the bond equals the face value. So here the bond is selling at par. And when the coupon interest rate is more than, when the coupon interest rate is less than market interest rate, or market interest rate is more than coupon interest rate, bond is selling at discount. Right. So in this case, the 2 years maturity bond, the present value is 1,000. For 10 years maturity bond, present value is also 1,000. For 2-year maturity bond, when the market interest rate increased from 6 to 7, the present value of the bond is 981.67. And when the maturity bond is 10 years, the present value of the bond is further falling to 928.94. So if you tabulate this result and as shown in the slide, the percentage change of 2 years bond is minus 1.8 from its 6% to 7%. So we are subtracting 981.63 from subtracting 1,000 from 981.63 divided by 1,000 to get the percentage change. And for 10 years bond, the percentage change is 7.2. So it means that when the market rate is increased to 7%, the bond price fall just as you would expect. The short-term bond lost less of its value than the long-term bonds. This is due to the effect interest rates and time have on the present value, which you've studied in chapter on time value of money. Because of this effect, long-term bonds are more interest rate sensitive than the short-term bonds, meaning that long-term bond prices fluctuate more in response to changes in interest rate than do short-term bond price. And this is what the slides illustrates. The bond that matured in 2 years decreased in price by 1.8% in response to the market rate increased from 6 to 7%. The 10-year coupon bond decreased in price by 7.2%. The longer the time to maturity, the greater the price sensitivity to interest rate changes. The price sensitivity is referred to as an interest rate risk, which is one of the greatest risks associated with bonds. So the price sensitivity is one of the greatest risks associated with bonds. And this risk is originated because of the change in interest rate. So the next question is, does the coupon rate have any effect on the sensitivity of a bond's price to a change in interest rate? So to see the effects of coupon rates on bond price sensitivity, you need a starting point. In this case, the starting point is the price of each bond at 7% market rate of interest. Not that 8% coupon bond is selling at premium because coupon interest rate is more than market interest rate. And The 3% coupon bond is selling at discount because the coupon rate is less than market rate. And this is what it is, and that is confirmed by our calculation. So when the interest rate is less than coupon payment, bond is selling at premium, meaning the market price of the bond is more than the face value or the par value. And for bond Y, since the coupon payment is $30, the coupon interest rate is 3%, which is less than yield to maturity or interest rate, so the bond is selling at discount. So these are the prices of the bonds at 6% interest rate. Here it is the prices of a bond at 7% interest rate. The coupon payment, coupon interest rate remain unchanged in the second case when the market interest rate changed from 7 to 6%. So as this slide illustrates, the 3% coupon payment bond increased in price by 4.5% in response to the market rate decrease to 6% from 7%. The 8% coupon bond only increased in value by 4.2%. This tells you that low coupon bonds are more interest rate sensitive than high coupon bonds. So the percentage change in the bond price is more in low coupon bonds than high coupon bonds. So, and this is the question: which bonds are more interest rate sensitive? Is it short term or long term? Low coupon or high coupon? Or are bond price and interest rate directly or inversely related? If you are not sure of these answers, review the last few slides before moving on. So there are two key points to understand about bonds. The knowledge will help you not only in this course, but throughout your life if you plan on investing in bonds or other fixed rate investment. And these two key points are longer the term, and the lower the coupon rate, the greater the interest rate sensitivity. Bond price and interest rate are inversely related. An increase in market interest rates will decrease bond prices. A decrease in market interest rates will increase bond prices. This is the idea of the relationship between market interest rates and the bond. And now let's talk on the zero coupon bond. Zero coupon bond is purchased at a discount and pays no interest payments. The price of a zero coupon bond is simply the present value of a single lump sum to be received in the future. So you can buy zero coupon bond today for a price of $414.64. 10 years from now, you will receive the face value of $1,000. Notice that the price is computed based on semi-annual compounding. Right, so you are not paid any interest because the coupon bond with a zero coupon bond, so there is no coupon payment involved. And if you buy today at a market price, at the time of maturity, you will be paid $1,000. So the zero coupon bonds are computed on a semi-annual basis to be consistent with coupon bond computations. And if you're using financial calculator, this is how it can be obtained. So the question is, while no interest payments are actually paid on a zero coupon bond, interest is implicitly paid by the firm and received by the bondholder on annual basis. How do you compute this implicit amount? Right. So the first step is to compute the price of the bond at the time it was issued. The second step is to determine the price of the bond after 1 year. The difference between the two prices is the amount of implicit rate or implicit interest, which is a tax-deductible expenses for the issuer and tax income to the bond holder. So what we are doing is we are finding the price of the bond at the time it was issued. So the maturity of the period is a 20-year zero coupon bond. The rate of interest is 6.75 and assume a semi-annual compounding. So the number of periods will be doubled. So it will be 40. It has to be divided by 2, and there is no coupon payment involved. So we use this equation, or you can use the Excel to find out the value. And the present value of the bond is 260.08. The second step is to find this. The second step is to find to determine the price of a bond after 1 year. So after 1 year, the maturity period will be 38 periods. Yeah. So the price of the bond is 283.28. So the implicit interest is the difference between two. So is $18.20 in our case, and this implicit interest is calculated each year using the same method because market price of the bond fluctuates with the number of years. So the compare the price with 18 years remaining and compare the price to the price of 283.28. Similarly, you can find the present value of the bond price at 18 years, 17 years, and compare it with the 18 years to find the implicit rate in that year. So this is how you can find find the implicit interest rate for zero coupon bond. So this is all about the bond valuation, and I hope this will help. Thank you.